Hi and welcome back to Sustainable Teacher. If it is your first time here, my name is Leticia and I'm glad to meet you. And if you've been here before, I'm happy to see you again. In today's video, we are going to talk about robotics. What is a robot, what is robotics, and the main parts or components in a robot. If this video sounds interesting to you, please subscribe, hit the notification bell, and if you like this video, give it a thumbs up. Nowadays, we talk a lot about robots and robotics and how robots will help us to do daily tasks or how they will do work that we don't want to do or that they are not safe or that means they are dangerous or these kind of things. But the thing is that even if we have the concept of robots and we can imagine R2-D2, the Star Wars robots, but the thing is that if I ask you what is really a robot and how it really works, probably you don't know how to answer. So today we are here to get the answer of these questions. Robotics is a branch of technology that mixes mechanical engineering, electrical engineering, and computing or programming. So we combine these three branches of knowledge to make robots work, like move, interact. Usually when we talk about robots, we think about androids, like the one we have in the picture. They look like people and they perform actions like people do. The thing is that this is not the only type of robot that we have, and I'm gonna give you a general definition of what is a robot. I'm fighting with this lift today, come on. A robot is a programmable machine, a machine that can store a program, read it, and use it to perform actions. And the important thing is that it is able to interact with the environment and change the answer, the reaction, depending on the conditions in the environment. And that's the difference with an automaton. An automaton is a simple machine that has a set of instructions, and the automaton will always repeat the same instructions in any condition. Okay, so imagine we have a simple machine like a coffee maker. But the difference between this and a robot is that the answer of the robot will depend on the environment. Imagine that I set a cappuccino, okay, and I forgot to put my cup on the coffee maker. Of course, if this is just an automaton and you push cappuccino button, the coffee will go out without the cup and will be spilled all over the place. But if it is a robot, even if this is a really simple robot, it will say, hey, you don't have a cup, please put a cup before the program starts. These are simple examples. There are lots of different types of robots, and we can classify them in mainly two types of robots: software robots and hardware robots. Software robots, they don't have a physical appearance, they just computer programs, but they are able to interact somehow with the environment or with other programs in the computer or with users, and they will modify their answers depending on this, and that's why they are considered robots. Usually the robots by excellence are hardware robots, which are robots with physical pieces, with physical components. There are thousands and thousands of examples. We can say that the four main examples could be, of course, android robots that have the shape of humans. That's why they are called androids. They could be used as assistants to people. They can be used to work like guides in exhibitions or to help people with disabilities. It depends on the use. Then we have bionic robots, which just simulates different parts of human bodies, but they are not the whole human body like androids. It could be arms, it could be legs, and they can grab things and they can run. This is a bionic robot. We also have cyborgs, which are really similar to bionic, and maybe they combine different parts of human bodies but not a whole body as its own. And finally, another typical examples are nowadays explorers. They are used mainly in Navy, so they can explore fields that can be safe for people, and if people go there, they can die. So they send a robot, they explore the area, and if it's safe, humans can go later. The example by excellence of an explorer robot is the Mars rover, which is the robot that was sent to Mars to check Mars surface and the conditions, the composition, and these kind of things. Robot has a kind of structure, a kind of architecture is called, okay? And the different parts of this architecture are, for one part, the control unit is usually the motherboard that we use in programming. There is a motherboard, is the processor of, like, the brain of the robot. And then we have different type of structures around the body of the robot, and these structures are classified into two main types, which are sensors or actuators. Sensors are the components in charge of taking information from the environment and send it to the motherboard, the control unit. The control unit will analyze the information and will give an answer, and this answer is performed by the actuators. In the case of the Roomba vacuum cleaner, if we think about this robot, the sensor could be the infrared sensor or the ultrasound sensor that will check that if there is or not something on in the front of that robot that can hit or the stairs or whatever. So the thing is that the sensor detects the object in front, it sends the information to the control unit, and the control unit say stop and turn left or turn right or whatever, and the motors inside the robot will change the direction, and the result will be that actuators will change the direction of the robot. Focusing on this, if we think about hardware robots and examples I gave you, most of these robots can move. A movement is made using different joints, different mechanical parts that are joined, and usually between each joint there is a motor that can change the position, usually a servo motor. We will talk about this in the next slide, that will change the position of the different parts in that joint, okay, the different mechanical parts. And it is interesting to check that there are different type of movements, like linear movements, like up and down, right and left. I always say right and left, I don't know why, forgive me please. But we can also have rotary movements, okay, like oscillation or just 360 degrees or 180 degrees turns. And there is an important thing to take into account when creating a robot with joints, with mechanical parts that have to be movable, okay, which is the degrees of freedom. And that means the capacity, the ability of that robot or that part, the mechanical part of the robot that can move, and how freely can it move. If it has more degrees of freedom, that means that it is more freely to move. And the degrees of freedom depend on the number of directions that movable part can have. So if we can only move in one direction, it's 1 degree. If we can move in 2 directions, it's 2 degrees. Actually, we can think about this with our body, okay? In the case of my head, I can do mainly like up and down or right and left. Well, I can do this diagonal thing also. So I can move in 3 different directions or axes, okay, in the space. So up and down, right and left. In this is a rotation, okay, but and this one is a different rotation. So I will have 3 different degrees. Usually robots have 1 degree, 2 degrees. If they are really complex and like in supply chains and these kind of things, they can have 3 degrees. And if we want to calculate the total number of degrees of freedom in a robot, we should add all the different degrees of freedom in each joint. And to finish with this video, I told you that the component that moves these mechanical parts in robots with joints are motors, and we have three main types of motors. Direct current motors. By the way, direct current is related with a video that is already uploaded. I will leave it in here, okay? So we have motors that they just turn around in one direction, or in two senses, in one direction all the time. In one of the two senses, it depends on the polarity of the wires and the battery, okay? And it will turn and turn and turn and turn, and that's all. Then we have servo motors, that are motors that can have moves like 180 degrees or 90 degrees, like this, okay? They are used in doors, for instance, to open and close doors automatically, or in bionic arms. And the last type are stepper motors, and stepper motors are motors that the internal structure of these stepper motors is more complicated, and it can change direction, and the freedom of movements of these kind of motors, it's much bigger. And that's it for today. I hope that now you understand what is a robot, what is robotics, and the main parts of a robot, what is the difference between a sensor and an actuator. We will talk about this in future videos also, so don't forget about this. And of course, if you have any question, leave it in the comments, and see you soon.